If you've ever wanted to know what's inside a thermoelectric cooling module, you've come to the right place, because I'm going to show you in this video. So here are two of these typical modules that operate at 12 volts, around 75 watts, and are very inefficient. They only use about 11% of the energy that passes through them. The rest goes up as heat. But they are pretty good at getting down to pretty low temperatures. And between the hot side, which is if you look at these wires, the red wire to the right, the hot side would be the bottom, and the cold side would be the top. So that's how you know which one is going to be hot and which is cold. So the hot side and the bottom side can achieve a 70-degree temperature differential. So if the bottom side was, say, 0 degrees, in theory you can get the top cold side to minus 70 degrees. Now these things have a temperature cutoff. The solid state components within them fail to operate below minus 100 degrees centigrade. So you can't really get to liquid nitrogen temperatures with these. And that's the one downside of them. They can be stacked to achieve even lower temperatures. But the problem with stacking is they become less efficient. So there's your typical modules, and I cut one of these open. They have, let me show you what they have. So they have alumina substrate on the bottom and top. The alumina is, in between the alumina is sandwiched the solid state couples. And then the whole thing is sealed with silicone sealant on the edges to make them kind of waterproof. So I cut one of these open, and this is what's inside. So each one of these things that you see here is a couple, which is basically a couple is a pair of series connected bismuth telluride, so bismuth and tellurium, bismuth telluride cubes. These cubes are known as dice, and there are a whole bunch of them. They're all connected in series, and then the hot and cold surfaces are connected in parallel to the ceramic. Now the great thing about ceramic material is it's a great structural support, it is a great thermal conductor, and it's also a great insulator. So it has the correct properties that you need for one of these units. Each of these little couples or pairs consist of an N-type and a P-type of bismuth telluride. And let me just show you what I mean. So they're connected in a zigzag pattern, as you can see here. This is copper. The copper is soldered onto the dice of bismuth telluride, and each couple consists of an N-type and a P-type. You should have an equal number of P-type and N-type dice in your typical unit. What happens is when electricity is passed through these, current flow is balanced. So the P-type, which are known as hot junctions, cool down, and then the N-type, which are known as cold junctions, warm up, so that there is balance of the electrical flow. And as you can see, there are many, many couples in one thermoelectric module. And then the couples are connected in parallel to the alumina plate. So they make parallel thermal communication with the alumina. These things can also be used for heating, and the temperature limitation on heating is the melting point of the solder. And on a final note, bismuth telluride is toxic. In fact, tellurium compounds are toxic. And so when you open one of these modules, there's quite a bit of dust that's released, and it gets pretty much everywhere. So you have to avoid breathing in the dust and avoid exposure to the bismuth telluride for obvious reasons. So just thought I'd show you how one of these things works, and give you a little bit of an overview and show you exactly what's inside one of them. Thanks for watching, folks, and don't forget to subscribe and check back for more videos.